alaikum. My name is Yasir Jamal and I'm joined by Yahya Ansari and Muhammad Abeer and today we're going to be talking about Gauss elimination method in computer science. Uh, Basically, Gauss elimination is just about eliminating the pivot rows, like the ones in between. We have to make a matrix, and the lines in between the diagonal values have to be 1, and the values below the diagonal 1 have to be 0. That's pretty much it. And today we're going to be explaining that method in detail. We'll start off with the slides. Muhammad Abeer, can you please introduce yourself?
Assalamu alaikum everyone. Today our topic is Gauss elimination method in computer sciences. First of all, I will introduce you with the topic. The Gauss elimination method is a very powerful mathematical algorithm used in computer science to solve systems of linear equations. And now moving towards the next slide, uh, we got what is basically the Gauss elimination method is. It contains three methods or three elimination techniques. Those are a mathematical technique. The Gauss elimination method is a mathematical technique used to solve systems of linear equations by transforming a given system into an equivalent and simpler one. And the second method is about row operations. This method involves using row operations to eliminate unknowns from the equations, making it easier to find the values of the variables. And now moving towards the third method, that is pivoting. Pivot elements are used in the algorithms to ensure numerical stability and accuracy during the elimination process. And now moving towards the next slide, we got the basically algorithm overview of Gauss elimination method. Step one is that forward elimination. The algorithm begins by transforming the system into an upper triangular form through rows operation and then eliminating unknowns along the way. And then the step two, that is back substitution. Once the forward elimination is complete, the algorithm performs back substitution to find the values of the variable starting from the last equation. And the third step we have is solution validation. The obtained solution is validated by substituting the variable values back into the original systems of equations to check if they satisfy all the equations. And then moving towards the next slide, we got basically the implementation of Gauss elimination method in computer sciences. Uh, Mainly, we got three implementations. Those contain the pseudocode, the variable representation, and the common programming languages. First of all, with the pseudocode, we have the Gauss elimination method can be implemented in computer sciences using the pseudocode that outlines the step-by-step procedure to solve system of linear equations. Then the second implementation is variable representation. The algorithm utilizes matrices and vectors to represent the coefficients of the variables and the constant term in the equations. And the third implementation of Gauss elimination method in computer sciences have common programming languages there are popular programming languages used for implementing the Gauss elimination method that include Python, C++, and Java. And in fact, the code is all about Python languages. And now Yahya Ansari will explain the rest of the slides. Over to you, Yahya.
Assalamu alaikum everyone. As we know that today we are discussing the Gauss elimination method. So here I will be explaining the applications of Gauss elimination method. So first of all, we have in engineering and physics, like solving systems of linear equation is a common task in engineering physics using Gauss elimination method. It is used to solve problems involving the analysis of circuits, structure analysis, fluid dynamics, heat transfer, and other physical systems. And then we have another applications like economic and finance. Basically, in economics models and financial system, it involves solving like large number of systems of linear equation. So Gauss elimination method is employed there. Then we have like machine learning. Gaussian elimination is used also in machine learning and other of the domain like finance and chemistry. Now we are moving to next. We have advantages and limitations. So basically, if we talk about the advantages and limitations of Gauss elimination method, so the Gauss elimination method basically is known best for its efficiency. Mean it is efficient in solving large systems of linear equations, and compared to other methods, and we have like increased accuracy in Gauss elimination method. Basically, it helps prevent numerical instability, and then we have like in limitations, it's singularity issues. Like this method can face challenges when the system is singular or in conditional. Then, if we talk about the conclusion, then I can say it's a powerful tool, Gauss elimination method, in computer science because it provides efficient and accurate way to solve system of linear equations. And then we have its broad applications, like from engineering to any other domains of the finance, chemistry, physics. We have its numerous applications like real world problem which can contribute to the advancement. And if we talk about essential understanding, so having a strong understanding of Gauss elimination method is like very crucial for a computer science professional, and it helps in dealing with the linear equations and their algorithm. So that's the applications of Gauss elimination method. Then we have like advantages and limitations, and in the last we have studied the conclusion. Now back to Yasir, and we will see how we can implement the Gauss elimination method in Python.
Thank you so much, Abeer and Yahya, for explaining the slides and about the Gauss elimination in theory. Right now, I'll be explaining the code that how Gauss elimination is implemented in Python. So let's move towards the code. So we start off from the start. First, we will define a method called Gauss elimination method and use two parameters called coefficients and constants, and then we will assign a variable which will be equal to length of coefficients, and then we'll apply a for loop for I in range. This is for forward elimination, and then pivot row will be equal to I. So our variable called pivot row will be equal to I, and then we'll apply another for loop, and basically the parameter in this will be I plus 1 and comma n, and then this is basically to find the pivot row, uh, and then coefficients j I is greater than abstract coefficients index pivot row and I, and then we will swap the current row with the pivot row. So this is what we will use for swapping coefficients index I and coefficients index pivot row equals to coefficients index pivot row and coefficients index I. So once we are done with the swapping, we will make the elements below the pivot 0. So for that we will apply a for loop that for j in range I plus 1 comma n, and then we'll implement a variable called factor, and the factor will be equal to coefficients of j and I divided by coefficients of I and j, and then coefficient of j will be minus equals to factor multiplied by constants of I, and then we'll apply another for loop for k in range I n, coefficients of j k minus equals to factor multiplied by coefficients of I and k. Then we'll move on to back substitution. Basically this we'll apply a variable here called solution, and then we will give a value in the index I0 multiplied by n, and then we'll apply a for loop, and in the for loop we will have n minus 1 minus 1 and minus 1, and then we will use the variable solution that we had declared earlier, and then the solution of I equals to constants of I divided by constants of I and I, and then we apply a for loop called for j in range I minus 1 minus 1 and minus 1, and then constants of j will be minus equals to coefficients of j and I multiplied by solution of I, and then we'll make the solution return. So for that we will write return solution, and then and then we'll provide a method for printing the header, and then we'll define a method for getting matrix input. So in matrix we have rows and columns, so we'll declare that in the parameter, and then the matrix will be like an array, and then we'll apply a for loop, In the for first we will have I, and I will be our rows, and then the row will also be equal to an array. And then for j in range columns, our j will be the column and our I will be the row. So we'll declare that, and then we'll declare a variable called value, and then that value will be float, and then we'll ask the user for an input that for so that they can enter the coefficient for the row and column. So we will declare that in float, and then we will append the row with the value, and then we'll append the matrix with the row, and then we'll make the matrix return. And then we'll implement another method called get constants input. So we'll basically get the constant of the we'll get the input of constants in rows. We'll declare constants as an array, and then we'll apply a for loop in range rows. So for since our I is rows, we will do the same thing. We will declare a variable called value, and we will ask for the constant for the equation in float as input, and then we will append the constant with the value, and then we'll make the constants return. And then finally we have the main method, where we will be printing our header and asking, and we'll print that enter the number of equations in the system. And then we have a variable called number underscore equations equals to int input. So our input will be an integer, and then we'll print enter the coefficients of the system, and then this is where we'll be writing the coefficients as input. So we have the variable coefficients that we wrote earlier, and then we use the method matrix input, and we include the parameters that we had for matrix input, and then the same thing for the constants. And then we will write the variable solution, and then the solution will be equals to the method that we first declared here on in the start, Gauss elimination method. And then inside that we will write coefficients and constants, and then we'll apply if else condition, that if solution is not none, then we'll print the solution is, and then we'll apply a for loop inside it, that for I value in enumerate solution, print I plus 1 equals to value. And then we'll apply and if that's not the case, then we'll apply the else condition, and in the else condition we'll make the program print the Gauss elimination method did not converge. So let me show you by running this code what I mean. Enter the number of equations. So we have to write in total of 9 numbers in the matrix, since it's a 3 by 3. So we'll write 2 we can declare how many rows and columns we want. So let's say we want a 2 by 2, so there will be 2 columns and 2 rows. So let's say for the first one we write 5, and then for the column 2 we'll write 4, and then for the column for the row 2 and column 1 we'll write 2, and then for the row 2 and column 2 we'll write 7. And then it will ask us the constants of the system with which the equation is equal to the answer, that is after the equation, after solving the equation. So for example, let's write 4 5. So we will get the values of x1 x2, that is 0.2 and 0.62. Now let me show you this with 3 by 3 matrix. So let me learn the code again, and then we need a 3 by 3 matrix, so we'll write 3 here. And then for the first one we have 1 5 7, and for the second row 2 6 4, then for the third row 7 3 and 4. So the constants will be 1 5 8, and then it will give us the answer of x1 x2 and x3. X1 is 1.13, x2 is 0.89, and x3 is minus 0.65. So that's pretty much the basic implementation of Gauss elimination method in Python, and I hope you guys understood the implementation of the code and the slides. And with this we'll end our video. Thank you so much for watching. If you found the video interesting, please make sure to like and subscribe, and make sure to comment. And yeah, that's pretty much it. This program was made by Yahya, Yasir and Abeer, and visit our channel Tech Tribe Talks. Thank you so much, and with this Allah Hafiz.